Good morning and welcome back to another video here from the Off-Grid Garage in sunny hot. Let me show you. We've got 56, 58, 61 amps outside. 62! Isn't that amazing? Yeah, I'm looking at my 4S 12-volt battery here, where I have the JK, the 4S version, connected to. And I can see a deviation of 80 millivolt here. It's a bit too much, right? Thankfully, the Chinese industry has provided a solution for that. Yeah, who would have thought that Daly is actually doing active balancing now? And a few people have left comments under my videos that actually Daly is doing active balancing now with their BMSs, and the app has now the functionality of active balancing here, but well, it didn't seem to work with the BMSs people had. Long story short, this is not for existing BMSs. The BMSs from Daly, they have still passive balancing, and even they updated their app with an active balancing function now. The BMSs you all have at home, they don't have any active balancing at all. Daly does only passive balancing. Resistor bleeding off energy of battery cells which have a higher voltage. So nothing has changed. The only thing which has changed is Daly is actually making a 1 amp active balancer. This whole printing is a bit blurry here. It's not the best quality on their sticker. And guys, I bought them all. I bought the 1 amp active balancer and the 1 amp active smart balancer. This one comes with the usual Bluetooth UART connection, so we can hook up this app. And this one is just a dumb 1 amp active balancer, which, well, basically the same as this one, right? And both balancers come with their usual balance leads here. I have already connected some ring lugs to it, so we can hook it up to the battery immediately. So the dumb version of the active balancer here comes with a 4-port, comes with a 5-pin port, and the balance cable clicks in, and this connects to your battery in the usual style. And then apparently it active balances with 1 amp. While the active smart balancer has 1 amp as well, comes with a 17-pin port, and look at this. They have cut off all the other pins because I ordered only a 4S version of this active balancer. So I'm keen to find out if these ones are actually active and if we can use this balancer for a 16S version as well. I mean, this is just... Yeah, and here on the other side, it comes with the usual UART Bluetooth for your Bluetooth module with the start switch. But it has also an RS485 port. That is interesting. So I'm not 100% sure what you could actually do. Do you just get the information out of that? Or can you change configuration or turn on the balancer via RS485? And both balancers actually come with screws underneath, which is always a big mistake. Okay, this didn't take long to remove the screws. Okay, let's see what's in the Daly active balancer with 1 amp. Oh, PCB. And capacitors. So we are actually looking at a capacitive active balancer, pretty much the same as the ones you can get from the Hanksaw store and Heltec. But this one has less capacitors. Well, this one is up to 5 amps and this one is up to 1 amp. Yeah, it says it over here. Balance current maximum 1 amp. So this is a max of 1 amp we can see here. And again, this is totally dependent on your voltage difference across the cells. The higher the voltage difference, the more amps these ones push around. So this one is not the NEEY Active Balancer here, which always balances with 4 amps. This is up to 1 amp. I was wondering if this little dot here is actually a light, but it looks like there is an LED here on the PCB, which then turns on once the balancer is active or connected or something. We don't know yet. All right, and the big one. Oh, nice inductor. This one is interesting because it has only 2 capacitors here. So this actually seems to work more like a NEEY Active Balancer here. It could be that this one here is balancing one cell after another, while this one here is more acting like the traditional capacitive balancers and balances all your batteries at the same time. So accordingly to the specifications for these active balancers, we have a start-up voltage of 3.3 volts per cell to activate each of these balancers. Well, I think the active one we can adjust the setting, but this one may start up at 3.3 automatically. I would rather like to see this at 3.4 turning on, but 3.3 is actually not too bad, because when you discharge such a battery pack here, the cell voltage usually goes down to around 3.2, 3.25 volts anyway. And only if you recharge the battery pack, then your cell voltage goes over 3.3, which then activates the balancer. So this could actually work. Yeah, and it says here again, the balance current is 0 to 1 amp. So I have reconnected the JK-BMS app so we can actually measure the cell voltages here all together. We can see cell number 3 is still high from our last test when we tested the 10 amp Heltec balancer, which was more like the 4.5 amp balancer. So one cell is actually over 3.3 volts. So in theory, this little guy should turn on and the light maybe turn on. Let's. I've checked all the voltages here for the connection cables. Yeah, green light. We've got a green light here. Okay, can we see cell number 3 declining? Got 70 millivolt deviation at the moment here. The balancer here of the BMS is turned off. At the moment I cannot see anything here. Let's see if we can measure 1, 2, 3. This is our, we can measure like 70 milliamps. Okay, let's measure all the other. This is cell number 4. There's 0. Cell number 2, 60 milliamps. And cell number 1, nothing. Okay, it's only between number 3 and number 2, while actually our cell number 4 is the lowest one. So I am actually expecting that it pushes energy from cell number 3 into cell number 4 now, because highest to lowest. But it doesn't seem to do that. So this is discharging. We've got a positive current. We are measuring here, so it's coming from the cell. And this is for cell number 3, which is our highest. So 50 milliamps, you can see here. And cell number 2, which is negative 60 or 70 milliamps. So this one actually gets charged at the moment. Current goes the other way. And you can see this spaghetti here coming out of this battery. I have left all the other connectors connected to the battery as well, because we want to compare. Let me get a normal 4S balancer. Just want to see how this one would handle this same situation. And the light is on, and this is balancing. 1, 2, 3. This is cell number 3. Current measuring, 400 millivolt. We can see in 0.4 amps. It discharges cell number 3 with. And let's measure cell number 4. Yeah, which is negative 150, so 150 going in here. Cell number 2 gets 350 milliamps, and cell number 1 gets also around 70-80 milliamps. But you can see here, this one is actually discharging our cell with 400 milliamps, while the Daly Active Balancer 1, 2, 3, 4 is so let's plug in the Daly Smart Active Balancer. All connected, no light. but we know from the BMSs we need to press this button here. Still no light, but it could be something different. Okay, let's see. Oh yeah, there it is. This is my battery and this is the balancer. Connecting. Then we go to active balance. Okay, balance current we can set, battery strings. Ooh, we can actually use a high temperature discharge protect. How does the balancer know what temperature the battery has? Balance, this is the deviation, 50 millivolt. And at 3.3 volts we should turn on the balancer. Cell high voltage protection. Why is this all in here? This has nothing to do with balancing. Balance switch. 1, 2, 3, 4, 5, 6. Now it's off. Balance current is 0 at the moment. Okay, I'm charging cell number 3 with 21 amps. So we are rising cell number 3. Do we have... Oh yeah, it shows us here. So cell number 3 is over 3.4 volts. But the balance status is still off. 3.3 at 3.3 balance open start voltage. Do all the cells need to be over 3.3 maybe? It wouldn't make sense. Because if you have a runner, you want to balance this immediately and not wait until the other ones have catched up. So this does not make sense. See, it has a temperature sensor there, but I think this is only internally, right? In the BMS. Still no balancing. Okay, let's charge this cell number 3 a moment and see what is happening. Still nothing. Okay, the green light is flashing. We are balancing now. The balancer is turned on. What I've done now, I'm charging the pack all together. See the positive here and the negative on the BMS. Charging all 4 batteries with 21 amps. And all the cells have now risen over 3.3 volts. And hence the balancer has turned on and we are charging with 0.8 amps, or balancing, not charging. Balance position it shows us. Great. Cell number 3. Yes, we can see it here. 1 amp. There it is, 1 amp. Nice. So if I turn off the charger again, we still have a deviation of 71 millivolt. Let's see. Yeah, they're still balancing. So it balances down to 50 millivolt. So if we set this one to 1 millivolt, set. Doesn't like this? No, it doesn't like this. I think 10 millivolt is the lowest the Daly does. Set. No, it's still not doing it. 20 millivolt. Yep, it takes 20 millivolt. So again, here we can see the 1 amp coming out of cell number 3. And it push it into, there's 100 millivolt going in cell number 4. Almost 1 amp in cell number 2. And almost nothing in cell number 1. Okay, I wonder if we disconnect this one again and put the little guy back on, if this balances better now as well, because all the cells are over 3.3 volts. Let's measure cell number 3 again. I've got the green light here, but no, there's nothing here. Is there any 100? No, 60, 30. No, there's nothing happening with this one. I cannot measure any balance current with the little guy. Okay, let's put this one back on and see how it would handle the situation. And we measure cell number 3 again, which is our highest voltage cell. And you can see 450 milliamps, 140, 200, 160 milliamps. It's not that great. Push this one back in. And press the dinosaur button. Yep, balancer is on. And let's measure cell number 3 again. And this is cell number 3. Yeah, we can see the 1 amp again. So that's cool. So it is as I was expecting it. This one acts more like the NEEY. So regardless of the voltage difference, apparently, it always pushes 1 amp. So let's turn off the charger and let this one sit for a while here and see if we can still measure this 1 amp. Because it should go down if the voltage difference goes down as well. But here at the moment we can see 0.9 amps. Cell number 3 gets discharged. Balance open start voltage. Okay, let's say 3.2. Set. Yeah, it takes it. I just want to prevent the balancer from turning off. 0.8 it shows, but we can still measure 1 amp. Yeah, that seems to work quite nice actually. Even better than these ones. But this one does not seem to work at all. Yeah, if we set the balance current to 0.5, go set. It's still balancing. Oh no, here it goes. Takes a moment. Yeah, 0.5, half an amp. 100 milliamps. Ah, it doesn't do 100 milliamps. As always. So 200 milliamps. Set. Yeah, goes down. There we go. 200 milliamps. Okay, so this seems to work. 1 amp. Yeah, goes up to 1 amp again. And I've also seen here the internal temperature sensor of the balancer goes up to 46, 49 degrees. It actually gets a bit warm. I'm trying the little guy again, but there's nothing. It's not balancing at all, or maybe with only a few milliamps or so. So this one doesn't seem to work. Let's try this one again. Yeah, at least here we can see 270 milliamps, 100 milliamps, 180. At least this is pushing a little bit more current, but this one doesn't seem to work at all. Okay, I have to go back to Daly and see what they are saying. That's not good. Okay guys, as you have seen, Daly has now an active balancer as well, active smart balancer. It is not as powerful as the NEEY, but is almost as expensive as one. No, actually it's not. I thought about the overall price I paid for both balancers, but the smart balancer is 57 Australian dollars and the non-smart balancer, which actually doesn't work, is $27. So all in total it was 100. I had this $100 in mind. So yeah, I must say this is actually a pretty good device here. 1 amp active balance current it gives you. It balances with 1 amp all the time, regardless of the voltage difference, I think. But I think if we go under 20 millivolt deviation, this one will stop balancing then, which is potentially fine. While again, the NEEY Active Balancer balances down to 1 millivolt deviation. You have a bit more of control in the NEEY Active Balancer. You can set a start and a stop threshold. Here you can only set a start voltage. And again, this one has only 1 amp, while the NEEY has 4 amp active balancing. So this one is actually not too bad for 50 bucks. And Daly, welcome to the world of active balancing. Finally. And yes, glad you asked. You can actually connect all of the balancers at the same time. They don't interfere with each other. They just all balance at the same time. And you can also turn on the internal balancing of the BMS as well. So you have 1, 2, 3, and 4 balancers now connected to this one battery. This works just fine. So if you have these really amazing A-grade batteries, and they are out of whack all the time when you fully charge them, you probably need more than 1 active balancer, right? So we still have all 3 balancers connected, and after close to an hour now, the Daly Active Smart Balancer is still pushing 1 amp across the system. So deviation has come down to 28 millivolt, but all battery cells are still above 3.3 volts. Which I actually cannot believe, because I just checked the because I just checked the JKBMS app and all cells were under 3.3. You can see the voltages down here, and this is what I measure. Okay, so cell number 1 has 3.29, cell number 2 3.29, so cell number 3 is our high voltage cell. 3.31 we measure, cell number 4 3.28, 3.3. What the hell is it measuring? Why is this measurement so far off? So it looks like the precision of the voltage measurement is completely off in the Daly Smart Active Balancer. I don't know what's going on here, but this is not what we actually have. Okay, so I'm discharging now the battery pack with my light bulbs here and the whole battery pack. I want to get this under 3.3 volts. Oh, that might be bright. Oh, all right, let's see the cell voltages here. Under 3. Okay, we are now under 3.3 volts, except of cell number. Now we are. Okay, we have to be quick here. So we are now under 3.3 volts. And the balancer is just starting again. Okay, so as soon as one cell goes above 3.3 volts, the balancer kicks in again. I can make it like this. Okay, let me discharge the battery again. Okay, discharging. Okay, we are under 3.3 now, and the green light has stopped. So I take the load away. Wait for cell number 3 to rise again. There it goes. 3.3. Cell number 3 is the trigger for our balancer. Okay, let's have a look if we can see this here as well. Yep, balancer is off. Balance current should go to 0. Yep, there it is. Okay, no load. Voltage is rising, and there it goes on again, and then balances with 1 amp again. And to be honest, I don't even know why the balancer is turning off and on at 3.3, because we have changed the turn on voltage to 3.2 volts. So everything above 3.2 should turn on this balancer. But it actually reacts to a 3.3, which was the default setting when we turned it on for the first time. But then I changed it to a 3.2, but it's still reacting to a 3.3. So something is not right, something is not working here. Yeah, 3.2 turns it on. And if I go to a 3.3, it turns it off. 3.2, 3.2, 3.3. So that's a bit weird, right? So this should trigger the balancer again, because all the cells are above 3.2. Okay, let's do the light bulb discharge again. Is one of the cells going under 3.2 maybe? Ah, cell number 2. It is cell number 2, which goes under 3.2 volts. And now it turns off, see? That's why. Ah, okay. And then we take it away and all the cells are above 3.2, and then it turns on again. It is not enough if only one cell is above 3.3 volts. All of them need to be above the threshold. Okay, this is now confirmed. And this is not good. Okay, so I'm only charging cell number 3 now, which is our high voltage cell anyway. So we should see cell number 3 now rising. But the balancer is still not turning on, even we have set this to a 3.3 volts. See there? Yeah, that is not good. That is a bad software design again. I mean, how hard is it to make this software correct, right? Why is the balancer not turning on if one of your cells has a higher voltage than the other ones and you are above the threshold? I was just going to recommend the Daly Smart BMS actually, but with this problem now, that means back to the drawing board, Daly. So I've got now 2 cells above 3.3 volts and nothing is turning on. No balancing happening. Well, at this point, I'm not sure if this is a hardware issue with the Active Balancer or if it is just a software issue with the app. Okay guys, so far this video from today, testing the Daly Active Balancers out here. And I must say, well, I'm a bit disappointed. I appreciate they put these ones in a plastic container, far better than having these bare PCBs, but the functionality is not there. This one doesn't seem to work at all for some reason. Maybe it's just faulty, I don't know. While this one here is kind of working, but the software is buggy again. The balancer as such seems to be fairly good because it pushes this 1 amp across your battery pack regardless of the voltage difference you have across your cells. Which is what we want. This is exactly what the NEEY Smart Balancer does as well. But the threshold you are setting in your app to turn on the balancer needs to be met by all the battery cells. Which is not good. This is just really bad, because if you have one cell running away, it will not get balanced at all. Nothing. There will be nothing happening until all the other ones are high as well. This is a really bad concept of balancing. Well, and then eventually your BMS will turn off because this one cell has then reached your over voltage protection setting. But I mean, we have to be cautious here with judging Daly for their first attempt to make an active balancer, because it took the NEEY Active Balancer 4 generations before it actually worked. And this is Daly's first attempt to make a balancer, and it kind of works, but not really. So at the moment, I would not recommend buying the Daly Active Balancers. Fall back to one of these balancers here, or if you want to spend a bit more money, buy the NEEY Smart Active Balancer. It balances with 4 amps, the software runs perfectly, and the app is now bug-free. I will link the Daly Active Balancers down under the video as well as on my website as well. If you want to purchase one and do your own testing, please go ahead and share your experience with that here on the channel. I'm really keen if I just picked up a faulty one from Daly, or if this one for some reason just doesn't work at all. I don't know. Yeah, if you have bought one of these active balancers already, let me know if yours work, if you could actually measure any balance current. As always, guys, thank you so much for watching. Thanks for all your amazing support here. You are wonderful, you are beautiful people out there. Until the next video, guys, you stay charged, stay safe, and thanks again for watching. See you then. Bye-bye. Wait, before I let you go, I have been in contact with the Daly official store via AliExpress and the chat function, and I must say, customer service, really top, really top. Fast responses, and they suggested some things I can try to get this little guy to work here. So they said, can you increase the voltage to a 3.4 volt and see if it works then? So I'm really trying to create a huge deviation now again between cell number 3 as our high cell and cell number 2 as our low cell. And here we've got 157 millivolt deviation at the moment, which I'm discharging cell number 2 and charging cell number 3. 170 is this one here. And we can now see 220, 230 millivolt, 200 millivolt around the balance current out of cell number 3. And this is a deviation of 200 millivolt, which is fairly high, and usually we don't have such a high deviation in a battery pack, right? So I guess this balancer is depending on the cell difference, on the voltage difference, on the delta, and at 0.2 volt difference, it balances only with 230 millivolt now, milliamps. Okay, let's try this guy here again, just as a comparison. And this is on, and here's cell number 3, and we can here see 1.8, 1.9 amps. We are balancing the same battery, same situation. This is the capacitive balancer against the 1 amp Daly balancer. So far better result here. 2 amps to 250 milliamps only, and we are at 315 millivolt deviation now. So I would not recommend this one here. It is, buy one of these here, far better result.